This is Algebra 2, Chapter 5, Unit 2, Part 1, Polynomial Functions. Polynomial functions. A polynomial function is a function of the form function of x equals a n x to the nth power plus a subset n minus 1 x to the n minus 1 power plus a subset n minus 2 x to the n minus 2 power plus, and you can go on with that, then a subset 2 x to the second power plus a 1 x plus a 0, and then you can go on. So let's kind of break that down and take a look at it. The coefficients of a subset n, a n minus 1, a1, and a0 are all real numbers. A to the n, as long as a to the n does not equal 0, and n is a positive integer. So you cannot have any negative exponents. A subset n is called the leading coefficient. And here's some examples. So we want to classify each polynomial function by degree and give its leading coefficient. So here is a table. You can go ahead and pause this video if you need to write this down. But we're going to go ahead. So we have the function of x equals 4. Well, that's a monomial. There's only one element. So, and it's not raised to the any power, so the degree is 0. And the leading coefficient is 4, meaning this number. Now we have the function of x equals negative 5x plus 1. The degree would be 1 because we have an x power right here, an x right here, and it's just the 1th power, okay? So our leading coefficient would be negative 5 because that is in front of our x. Next we have the function of x equals 12x squared minus 11x plus 31. Well, this is a trinomial, and here's our x term, our first x term, and with the highest degree or highest exponent is 2, so our degree would be 2. And our leading coefficient would be 12 because that's what starts us off with that highest exponent or the highest degree. Next, we have the function of x equals negative x cubed minus x squared plus 8x plus 1. Well, we always want to look for the highest exponent, the greatest exponent. In this case, it is 3. So we have a 3. That would be our degree, would be that 3. Now our leading coefficient is the number or integer before that x in that highest exponent. So in this case, it'd be negative 1. Although there's no 1 reflected here, we still know that there's always a 1 in front of the x if there's no other integer because we just drop off that 1. So that's our leading coefficient. Next, we have the function of x equals negative 3x to the 4th power plus x squared minus 18. So our highest exponent is at 4, which is also our degree. And so 4 is our degree, and our leading coefficient would be the negative 3 that's attached to that 4. Number 5, our next one is function of x equals 9 x to the 5th plus 2x4 minus x3 plus 9x squared minus 2. Well, we have a lot of exponents here, but we're still looking for that highest or the biggest exponent, and in that case it's 5. So our degree is 5, and our leading coefficient is the 9 that's attached to that 5. Next, we have polynomial parent functions. So we want to identify each parent function, then sketch a graph. Okay, so we have a constant, so function of x equals constant, and that's just going to be a straight line, straight across at x, okay? I apologize, at y. It's just going to go straight across at y. Our linear function is going to go diagonal, and it's going to be a straight line or linear, and it's going to equal x, okay? Our quadratic graph is going to look like this. We have x squared, and it's going to be a positive. It's going to be above the x-axis. And what a quadratic is really telling us is if we have a negative 1 squared, our y is going to be 1. If we have a positive 1 squared, our y value is still going to be 1. If we have a negative 4 squared, our y value is going to be 16. And if we have a positive 4 squared, our y value is going to be 16. It's just a U shape with that quadratic function. Next, we have the cubic function, or x to the third power. That is going to look like this kind of wavy line. Notice that it's not linear. It's not a straight line. Okay? And then it's just going to say, it's going to be negative still. Okay? So if you're multiplying, if your x is a negative number, then it's still going to be negative. If your x is a positive number, then it's going to be positive. So it's just going to go in the opposite direction. Next we have quartic, or x to the fourth. It's a lot like cubic and quadratic, it's a lot like quadratic in the shape because it's a U shape. And we know that if we take 2 to the fourth power, we're going to get 16 still. And if we take negative 2 to the fourth power, we're still going to get 16. We're just raising it. Okay, so if we have a negative or a positive of the same number, we're still going to get the same y value with the quartic. And the quintic is it's going to be shaped a lot like that cubic because we have an odd number for our exponent. So if we have a negative x, then that negative is going to remain there. End behavior patterns. Okay, so end behavior pattern, what is an end behavior? It's the behavior of a graph of f of x as it approaches positive infinity or negative infinity. The degree and the leading coefficient of a polynomial function determine the end behavior of the graph. The leading coefficient is significant compared to the other coefficients in the function for the very large or the very small numbers. So the sign of the leading coefficient is sufficient to predict the end behavior of the function. Now let's break that down into what it's going to look like for us. So this is how to graph a function on your calculator. So I want you to go to Window and set your values to the following. X minimum equals negative 10. X maximum equals 10. Y minimum equals negative 10. And Y maximum equals 10. Next, go to your Y equals button in the upper left-hand corner of your calculator and clear it out. Then enter the function. So it's going to look like this when you enter the function. Then hit graph, and it should graph that function. Now here are some examples. We have using your graph calculator, determine the end behavior of the following functions. We have the f of x equals 4x to the fourth power plus 6x cubed minus x. So go ahead and plug that into your graphing calculator. I plugged it into mine. Here's a picture of it looked like when I plugged it into my y button, or my y equals. And here is a graph of that function. Notice where the lines of the graph approach. Okay, so they're approaching, see the arrows? They're approaching upwards. Okay, so it's going to be positive infinity. As x approaches negative infinity over here on this left side, it's still going to be positive infinity up here. And as x approaches infinity on this side, so as x goes kind of like this, well, your y value, or the function of x, or your answer, is still going to be positive infinity. So you're looking for where those arrows, or where your function, the lines of your function goes. Okay, so the lines are approaching positive infinity. So on your chart, it's going to look like this. As x approaches infinity, the function of x approaches infinity as well. As x approaches negative infinity, function of x approaches infinity still. Now we have the function of x equals negative x cubed. So here is my calculator when I went ahead and plugged this in or graphed it in my y value. Notice that As x approaches infinity, so as x goes over here to infinity, our function of x is going down, so it's heading towards negative infinity, okay? As our x approaches negative infinity or goes this way, our function of x is positive infinity, is going up. Now I would like you to try numbers 2, 3, 5 through 6 on your own. Go ahead and pause this video while you try those. Here are the answers to those problems. Go ahead and pause it while you write your answers and check them out. Now draw sketches to determine the end behavior of the patterns. So if we have a positive leading coefficient and an even degree, then our graph is going to look like this. Okay, it's going to kind of be a U shape. If we have a positive leading coefficient but an odd degree, it's going to kind of be what we see in that cubic or quintic graphs, where it goes opposite directions. If we have a negative leading coefficient and an even degree, then it's going to look like an upside down U. If we have a negative coefficient and a negative leading coefficient and an odd degree, it's still going to look like that cubic quintic, okay, where it's going to go opposite directions. Determine the sign of the leading coefficient and the degree, and state whether the function has an even or odd degree. So number 7, here is the line for number 7. We can tell that this is in that upside down U shape. So when we go to our chart that we just wrote down, when it's in that upside down U shape, when they're both heading to negative infinity, then it's a negative and it's even degree. Number 8, we can see that it's that kind of quintic or cubic. It's going opposite directions. Okay, so we look at the arrows, so it's going down when x is negative infinity, and it's going up when x is positive infinity. So it's a positive leading coefficient and odd degree. And that is it for chapter 5, part 1. Go ahead and pause the video and stop the video and then move on to part 2.